Welcome to Warwood Tool's Inside the Forge. This series will take you through the 172-year story of Warwood Tool. We will take you through the founding and history, as well as taking you behind the scenes to see how we forge the world's finest hand tools, right here in Wheeling, West Virginia. Today's episode is about Warwood's origins and the community of Wheeling, West Virginia we call home. Steeped in history and forged by hard-working Americans. In 1854, English immigrant Henry Warwood moved to Martins Ferry, Ohio, bringing experience from Pittsburgh's steel mills. He opened his own tool shop, laying the foundation for the Warwood Tool Company. This shop evolved into a steam-powered factory, making mining and gardening tools for a growing America. 38 years later, the company was sold and relocated right across the river to the commercial hub of Wheeling, West Virginia. After more than a decade of growth, Warwood Tool moved to its current location alongside the Ohio River. As America continued to industrialize, Warwood tools went everywhere. Coal mines, railroads, construction sites, and even battlefields. Warwood tools have been used in every major American conflict since the Civil War. Most notably, the trench mattock was used extensively in World Wars I and II for digging trenches and fortifications. But while Warwood tools traveled across the country and overseas, the work itself stayed here, in Wheeling. Warwood Tool didn't just move to Wheeling, it became a part of it. The forge rose along the Ohio River as the town grew around it, shaping the neighborhood that still bears its name. For over a century, this factory has been a constant presence. It stands as a reminder of what built this town and what continues to define it. As the world changed around it, inside the forge, the work continued. Steady, deliberate, and rooted in craftsmanship. Today, Warwood Tool remains a productive factory, not a relic. Orders move through the building, tools move out the door, and the forge stays active. The factory continues to provide skilled jobs and steady work in Wheeling, contributing to the local economy and maintaining the manufacturing legacy of the Ohio River Valley. Warwood Tool is a reminder that American manufacturing isn't something that only existed in the past. Right here in Wheeling, it's still happening. The tools that leave here are built with the same grit and precision as they were 172 years ago. This series will take us inside the forge, diving into the process, the people, and the place that keeps one of America's oldest tool manufacturers going.
A sledgehammer is about as straightforward as a tool gets. But if it's not made right, you'll feel it with every swing.
Our sledges are used everywhere from railroads to construction, oil and gas, firefighting, and even mining.
To meet the demands of America's toughest jobs, the process starts right here with U.S.-sourced steel.
We got to get the steel hot enough to use it, but not hot enough to where it burns up.
If the heat isn't right, it affects everything coming afterwards down the line. Drop forging is where the sledgehammer strength comes from.
We use force from the drop hammer to shape it and make it durable.
And this is where we finish them up and finish the striking faces. Not many places do this step anymore. No amount of automation can replace the work of American craftsmen.
This step helps us control the hardness of the steel. A good sledgehammer is strong, not brittle.
This handle has to be solid, no movement. You can feel when it's right, the balance and the way it sits in your hand. This one's ready for work.
We're not the biggest tool manufacturer in the world. We make up for that by how much we care for every order.
There are many different weights and handle sizes for every job. But on our end, the goal is always the same, to make something that'll meet the demands of every job for decades.
Whether it's a sledgehammer, axe, bar, pin, or hook, heat is what allows the steel to move, take shape, and hold up for decades of hard work.
Steel doesn't move unless it's very hot, and it doesn't move right unless the temperature is just right. If it's too cold, you'll fight it, and if it's too hot, you'll ruin it.
These furnaces get our steel to the right temperature that allow us to forge it to get to the correct shape. That sweet spot is the difference between a tool that lasts and one that doesn't. This is how you get consistent shape and strength. And a tool that holds up under years of work and abuse.
The right temperature is really important when it comes to the dies because we want the material to flow, and in order to get it to flow, it all comes down to the design of the dies and the tooling and where we have room for the steel to move, because otherwise we're just going to end up wasting it, or we'll end up having not enough material to even form the part.
With the Bradley hammer, I'm able to work the steel longer and more gradually. The Bradley hammer has a different precision than the drop forge, but the heat's doing the same job.
There's no gauge to tell you it's perfect. You learn steel by being around it every day. The color and the way the steel moves can tell you a lot. This step allows us to lock in the hardness and protects the toughness of the tool. Too fast, the steel gets brittle, and too slow, it won't hold up over time.
No matter what we make, it all starts in the furnace. Our tools are used for thousands of jobs every day, and it all starts right here in our furnaces.
Heat allows for the highest level of craftsmanship, and it lets us do something that otherwise could never be done without heat.
Automation will speed things up, but it cannot replace experience and judgment. At Warwood Tool, craftsmen make the call. Every strike must be measured, precise, and intentional. That's something that only experience can provide.
You can't just put steel there. You really got to know how to forge it.
All right, I've been doing this job for years. The machines help, but it's my eyes and hands that do the job correctly. This hammer has been here longer than I have, but it's still just as reliable as the day I started.
I started 35 years ago. I started as a grinder. I ground for a couple years. Then I started on the drop forge, the bar roll, a little bit of everything after that. Yeah, we've had a lot of change here, and change is good. It's not easy, and where we're at now, we're on our way up.
Our legacy equipment represents decades of knowledge and experience. Maintaining our equipment is important for making our tools.
For us, craftsmanship is not about speed or volume, but it's about attention to detail and getting things right the first time.
With automation, if something's wrong, it's going to be wrong on hundreds of units. With Warwood Tool, if something's wrong, we can stop and fix it immediately.
Automation has a place here. For us, it's something that supports craftsmanship rather than replaces it.
You can feel it when you pick it up. Something made fast and something made right.
Our tools are used to do America's toughest jobs, and those jobs count on reliability. You get that reliability through experience and attention to detail, not just programming.
At Warwood Tool, our heritage has always been hand forged, and so as we look to the future, we try to find ways that we can supplement that and improve it, but never replace it. At Warwood Tool, we're always looking forward, making sure we can meet the needs of tomorrow's craftsmen.
For over 172 years, Warwood Tool has been built on forging steel by hand. But staying American-made doesn't mean standing still. To keep making the tools that America's toughest jobs rely on, and to support the equipment that makes them, you have to be prepared for what comes next.
Our CNC lathe is really special because it lets us produce ironworking pins that we've had for decades, but they've always been forged. And so now with this, we've got the capability of making them at a far tighter tolerance than ever before. Our broadhead bullpens are a great example of how the lathe really comes into play with production. We've got the perfect combination of forged tool on one end, but also precision alignment tool on the other end that we're turning on the CNC lathe. For us, we don't see it as one or the other, but rather it's a perfect combination of craftsmanship meeting automation.
Well, the CNC mill helps us use a pre-calculated model and build everything off of that so that it's also able to be reproduced. It helps a lot when you're doing a resync. Once you set it up one time and spend the time to set up your entire model and program, after that it's repeatable. It's a robot. Well, some of the equipment is out there, it's been in service for years. It starts to wear out, it gets old, it's metal, we're hammering hot steel together, so as it wears out, we have to go back and do a resync or, kind of hone back in the tooling that what it originally was. So in conjunction with the CNC machine, that's how we do it, and it'll recut and we resurface off, and that'll allow the tool to be back to new and be in tolerance. For new products, usually starts out with a design meeting and what we want the tool to be, what we want it to do in the end. Once we start the design of the tool, we kind of reverse engineer from the tool back through all the hammer dies, the trimmers, the punches, and everything that goes into making that tool. And then we start breaking it down into each individual part, starting with our stock, and then we machine it all and design it and machine it all. With all of our old dies and existing dies, over the years, talking over 150 years of dies and just random tooling that had no drawing to start with in the beginning. So how we utilize it is we take a 3D scan of something that's existing, and then we put it in the computer and we match. From there you can get dimensions, and solid models and everything, and you can calculate volumes for steel and all that. And that is what it's really the importance of it, because we can go and take something that's old and, you know, put it using new technology. We could go back in and kind of resurface those 3D surfaces, which is one of the hardest things to do machining wise, is getting an accurate 3D surface. So when we scan it, we can then have something to reference off of and match it and hopefully improve it and make it better, which we usually do.
The scanner puts a bunch of points onto the product, and then we kind of go through and take out the points that aren't needed and mesh ones together that are. And it gives us a good solid product of what it actually looks like and what we want to shoot for. So we can put it into our program and base everything off of that.
Our CNC machine shop's been absolutely amazing in keeping this old shop alive, because at the end of the day, parts break and you can't find replacements, so we can make them ourselves, but it's also key to our future and innovating, because we're able to produce all of the tooling in-house at just an incredible speed and precision.
Standing on the shoulders of giants, you know, you take everything that you can learn from the models and from the scans and from how you actually see it working in progress, you know, the human element of it. Ergonomically speaking, you know, how does that tool get handled? You know, how does a person hold it? And is there what worked, what didn't work? So you're learning off of that and those older processes, and you try to improve them, you know, using logic, basically, using logic and engineering know-how, you know. A CNC machine doesn't necessarily take someone's jobs or say anything like that. It's replacing an older manual machining style of actual machining. So you're doing all the same things, you're just doing it using newer technology. I mean, a mill's still a mill, still using the same type of tooling. Some of it's a little more updated, cut at higher speeds, higher RPMs, that's what these do. And it's more controlled, because a human just simply can't be traveling at, you know, 100 inches a minute and making sharp turns and making every step accurate to, you know, 5/1000ths or 1/1000th or half a thousandth of an inch, you know. So that's where it's supporting us, because now we can make those paths and then make them, you know, reproduce them. As far as the machinery or the tooling that you're making, when it goes out there onto the floor, you know, the better product you give them to start out with, they will figure out, and they do figure out, you know, how to get it made. And they can also communicate back with us, tell us what we need to do or what they think we need to do to make their job easier, to make the part better.
Future of Warwood Tool is highly dependent upon this new CNC capability, because it's what gives us the flexibility to bring in all this new stuff and find a way to make it work with our old equipment and our old processes.
Forging the future doesn't mean leaving the past behind. It means protecting it with the right tools, the right people, and the right capabilities. This is Warwood Tool, built on tradition, ready for what's next. Thank you for joining us for Inside the Forge. Make sure to subscribe to our channel, and if you enjoyed this video series, leave a like and a comment what you would like to see us do next.